Download this code from codegive.com, link in the description below. Articulation points and biconnected components. Articulation points, or cut vertices, in a graph are vertices that, when removed along with their incident edges, increase the number of connected components in the graph. This means that if you remove an articulation point, the graph becomes more disconnected. Biconnected components are maximal subgraphs such that any two vertices are connected to each other by at least two vertex-disjoint paths. In simpler terms, removing any single vertex from a biconnected component does not disconnect it. Why are they important? Network reliability. Understanding articulation points helps in network design, ensuring redundancy. Graph analysis. In social networks, articulation points can identify influential individuals whose removal would fragment the network. 5-to-2 articulation point. The term 5-to-2 articulation point refers to a specific type of articulation point that is characterized by its properties in a graph. Specifically, a vertex is a 5-to-2 articulation point if it has a degree of at least 5 and when removed, it causes at least two components to form in the resulting graph. Finding articulation points and biconnected components. We can use depth-first search, DFS, to find articulation points and biconnected components effectively. The algorithm works by maintaining discovery and low values for each vertex. DFS algorithm overview. 1. Discovery time, the time when a vertex is first visited. 2. Low value, the lowest discovery time reachable from a vertex, considering back edges. Steps to find articulation points and biconnected components. 1. Perform a DFS traversal of the graph. 2. For each vertex, check the discovery and low values. 3. Determine articulation points based on the conditions derived from these values. Python code example. Explanation of the code. 1. Graph class, defines the graph structure and methods. 2. Add_edge, adds an edge between two vertices. 3. Articulation_points_util, a helper function to perform DFS and update discovery and low values. 4. Find_articulation_points, initializes the variables and calls the utility function. 5. Example usage, a simple graph is created, edges are added, and articulation points are identified. Conclusion. Understanding articulation points and biconnected components is crucial for analyzing networks and ensuring their robustness. The provided code demonstrates how to implement the necessary algorithms in Python, and the concepts can be applied to various fields, including computer networks, social networks, and more.